Bismillahirrahmanirrahim. So, inshallah, today we are going to discuss about the chapter Effect of Heat on Matter. The very first topic that we have in this chapter is heat and temperature. Okay. Now, I know that you all have actually a general idea about what heat is and what temperature is, right? Okay. But today we will try to know a little bit deeper. Okay. Now, come to page number 162 page. Okay. This page is very important for MCQ. Very important for MCQ. And inshallah, when I'm done with this page, inshallah, you will get to know something new that you didn't know about heat and temperature before. Okay. So please pay attention. তোমাদের ভিডিও অন রাখতে বলেছে দিতে অসুবিধা হয়ে গেছে তোমরা এত নাড়াচাড়া করো মনোযোগ দিয়ে শোনো ওকে ফোকাস অন what you are learning not how you are looking okay so heat is a kind of energy
পেজ নাম্বার একটু বলেন
হ্যাঁ কি নাই
পেজ নাম্বার
160
162 page 162 page okay
yes sir
acha now heat is a kind of energy we already know that energy has different forms electrical energy chemical energy light energy several types of forms of energy are there right so one of them is heat we have seen that energy can do work okay whenever we have some energy we can utilize it to do some work we know this from the chapter work power energy right we know that if I have 220 joule of energy I can do 20 joule of work okay now by applying force it is possible to displace a body in the direction of the force yes whenever there is a body we apply some force on it we can cause some displacement right and whenever there is a force and some displacement due to that force we can say that we have done some work because from the definition of work if you remember the definition of work is the force into displacement so if there is force and there is displacement due to the application of force then we can say that we have done some work for example heat is produced by burning fuel oil in a train or a car and this produced energy creates motion in the train or car now see whenever we are burning fuel okay in engine okay in car or you may say in train wherever we are using a vehicle we are actually burning the fuel and while we burn the fuel what happens heat energy is produced so that energy is used to take the vehicle forward okay so we can see that we are doing some work we are applying some force and some displacement is caused so definitely what is happening some work is being done so as some work is being done definitely some energy is being used which energy is heat energy okay so this new form of energy is called heat energy like light electricity or kinetic energy it is interesting that if we could see on the molecular level means every particle is formed of uncountable number of molecules right if I break each and every object I will see molecule if I keep on breaking I will be at last I will get molecules
atom
right? Okay if you break the molecule then you will be getting atom I hope you already know about atom and molecule from chemistry right okay
yes.
I don't need to discuss that in details that means looking at any substance if we see its molecule we should call it kinetic energy instead of heat energy this is a very important point okay even the grade 12 students doesn't have a clear idea about this because they don't pay actually much attention to it okay because this question actually does not come in the creative but very important for MCQ and somehow I have seen over my past years experience that students seem to neglect the MCQ part they focus more and more on creative if they solve 100 creative they want to solve another 100 creative but they don't want to study a single MCQ so my request to you will be always focus on MCQ because many times I have seen the students scoring very good in creative but still missing the A plus due to scoring very poor mark in MCQ okay so put equal emphasis on both of them Achha. So what I'm trying to say the heat energy is actually kinetic energy of which of whom the molecules okay each an object is formed of molecules. So if I take the kinetic energy of each and every molecule and I add it up, that will give me the total heat energy of the body. This is very important concept. Okay. Now you might say that, sir, every time there is not a kinetic energy, because in solid substance we know that the molecules are rigidly attached with each other, so they do not have any chance to move. They are not in motion. But the truth is that every particle has a little bit of vibratory motion. Okay, in solid substance, this vibratory motion is less, and in liquid it is a little more, and in gas it is the highest. They vibrate and they run here and there with the maximum speed. Okay, compared with the liquid state and solid state. In solid state, it is the least. Okay, so what we can say is the kinetic energy of the molecules is the least in solid, a little bit more in liquid, and the highest in gas. Okay, so according to that, if I ask you which one has the highest heat energy, will you be able to tell me? Solid, liquid, or gas? Which one will have the highest heat energy?
Yes.
Yes, this is a very important MCQ.
Yes.
Sometimes, student, whenever I put this question in the exam as MCQ, they become surprised. They say that, sir, how can we tell solid, liquid, or gaseous substance have the higher heat energy if you don't tell us the temperature? Okay, without knowing the temperature, if I just ask you of a particular substance, okay, let us say we are talking about any substance that is in solid state, and then we convert it to liquid, and then we convert the same substance into gas. Then what will happen? In these three states, you will have the maximum amount of heat energy in gaseous state and the least amount of heat energy in the solid state. Very important MCQ. Why? Because kinetic energy is maximum in gas and the lowest in solid. Okay, I
Sir,
hope
solid heat energy আছে?
definitely, because even though it is in solid state, every molecule have a little bit of vibrational motion. Okay, it is always there. So as there is motion, there is kinetic energy. If you remember watt power energy, we know that whenever there is a
Yes.
motion, there is kinetic energy, because
Yes.
a body can get into motion only if it has kinetic energy. Okay, so as there is
Okay.
vibrational motion, there is kinetic energy, and if there is kinetic energy, there is heat energy. So kinetic energy is actually the heat energy. Okay, so or
Yes,
we can
sir.
say that heat energy is the kinetic energy of all the molecules. So this is a very important concept. Okay, because what we mean by heat energy is actually nothing but the combined kinetic energy of the molecules of a substance. See, this is what I have been explaining. When the molecules of a solid are heated, the molecules vibrate about their fixed position. See, in a solid substance, the vibrational motion is less, but when you start heating it up, what will happen? You are supplying energy to it, and that energy will be used by the molecules to increase their vibration. So their motion is increasing, their kinetic energy is increasing, we can say, right? As they are getting energy, their kinetic energy will increase, and as the kinetic energy is increased, the motion will increase. So as a result, what will happen? As the vibration is increasing, the molecule, will start overcoming the bonding between them. In solid substance, what happens? They are tightly bonded. Okay, the attraction force between them is very much high. That is why they cannot actually move. Okay, no, they don't have much opportunity to move or vibrate. So they vibrate with a less amount of amplitude. But when we supply energy, what happens? They start vibrating with a larger amplitude, and as a result, what happens? They start overcoming the attraction force between them. Okay, so then it slowly starts converting into liquid. Okay, so when the bonding becomes weaker, it converts into liquid, and then if you keep on heating it, what will happen? The bonding will be lost totally, and they will become gaseous substance. In gaseous substance, we know that there is no bonding, no attraction or repulsion force between the molecules of the substance, right? So this is what is happening. Acha. So the more the molecules are heated, the more the vibration increases. Okay, if the molecules are heated enough, molecules become free by overcoming their intermolecular forces. Intermolecular forces means, I want you to understand this. Okay, whenever a train runs between two cities, it is called an intercity train. That means between the cities it will run. And many times you will hear this word, that inter-university football tournament. That means this football tournament is between the universities. So inter-university. So here intermolecular means between the molecules. Forces means the force between the molecules that we know as attraction force, right? Okay. So try to understand each and every term. Then we call it a liquid. So see, they overcome the intermolecular force and they become liquid. Then the molecules move randomly among themselves. Since the molecules are in motion, they have kinetic energy. The more the molecules are heated, the faster they will move. Okay, because the more they are heated, the more energy we are supplying. So as a result, using that energy that is being supplied to them, they will start moving faster. Okay. If the molecules are heated more, they may be completely free from the intermolecular force. That is the gaseous state. Okay, then we call it a gas. The more a gas will be heated, the faster its molecule will move. The more the velocity, the more the kinetic energy. We know that, right? Because kinetic energy is equal to half mv square. If v velocity increases, the kinetic energy will also increase. And if kinetic energy is higher, heat energy is higher. Okay. Since we cannot see the molecules with our naked eyes, we can see their movement. So we try to understand the whole thing indirectly. We call it heat energy and try to explain the states of matter considering is at temperature. Now we are going to introduce the topic of temperature. Okay. I told you that the first topic is heat and temperature. They are closely related to each other. How? We will get to see. Okay. Achha. So we can say that the energy which is obtained due to molecular vibration or motion of a substance is called heat. Right? Due to the vibration of the molecules, the energy that is obtained, heat energy. As it is a form of energy like other energy, so its unit is joule. You already know that work and energy we calculate in joule, 20 joule, 50 joule. Okay. Achha. Now, previously actually there used to be another unit. Okay, before joule was introduced, another unit of heat was there, and I am sure that every one of you are familiar with that unit. That is, can anybody tell me
What, sir?
what was the unit of energy before joule was introduced? Now we use the energy or a unit of energy as joule, but before joule there was another unit of energy. So what was that? It is still actually used nowadays. Calorie. Okay. Whenever someone is trying to lose their weight, they will, actually become concerned about the amount of calorie is there in the food. Okay. Because the more calorie they take in, the more actually their weight actually increase. Okay. If you do not burn that calorie. Okay, acha. So what is the relation between calorie and joule? Okay, if you have a certain amount of heat in calorie, can you convert it to joule? Yes, we can convert. And the relation is something like this: 1 calorie is equal to 4.2 joule. Very important for MCQ. Okay. Sometimes what I do, I reverse the question. What I ask in the question is 1 joule is equal to how much calorie? And most of the students make this mistake. They just see, okay, joule and calorie. So it is 4.2. No. If you are going from calorie to joule, then it is 4.2. But if you are going in the reverse direction, 1 joule is equal to how much calorie? Then the answer will not be 4.2. It will be something different. What it will be? Let me show you.
1 divided by 4.2.
Very good. 1 divided by 4.2. Why? Because if I want to get 1 joule, I have to divide this side by 4.2, right? So if I'm dividing this side by 4.2, this side also be divided 1.2. Needs to be divided by 1.2, okay, to balance. So then 1 by 4.2, this one actually becomes 0.24. Calorie is equal to 4.2 by 4.2 is 1. So 1 joule. So 1 joule is equal to 0.24 calorie. Okay. So be very careful. Okay. From where you are going in which unit. Okay. Acha. Yes, they have also written
Calculator
third
is
about
showing.
word calorie, which is used in case of food. Food calorie means actually the amount of energy obtained from the definite quantity of food, and the unit for this is kilocalorie or 1000 calorie. Calorie is actually a small amount, that is why kilocalorie is used. Um, so, but we will not worry about this now. Here we will discuss heat energy, not the energy gained from food. Yes, we are not going to discuss about the details of this. Okay. Acha. Acha. Before I move to the next topic, I want to discuss a very important thing with you. That is, sometimes we feel that about temperature. This thing is about temperature. Sometimes we feel that by touching the object, we can actually tell the temperature, or we can make an assumption about the amount of heat energy it possesses. We actually cannot do that. Like there might be some cases, if you touch a body, you might feel that the body is hot, okay, and you may make an assumption that the temperature of this body is very high. But at the same time, some other person, if touches the same body, it is possible that he will feel cold, okay. So he will make an assumption that the temperature of the body is very low. Now, let me give you an experiment. You have to actually imagine it as I say it. Okay, just imagine it. Okay, let us say you have three pots or three buckets. One, two, three. Three buckets. In the right one, you have hot water. In the left one, you have cold water, hot and cold water, and in the middle bucket, you have the room temperature water. Okay. So hot water will have a temperature higher than the room temperature, and the cold water will have a temperature lower than the room temperature. Correct? Understood? Okay.
Or
Now,
again.
huh?
Or you can explain
Again.
this one again. You can say this one again.
Okay, three buckets of water. In the right one, you have kept hot water. Hot water means, let us say the room temperature is now 30 degrees Celsius. You have kept a water of 70 degrees Celsius here. That means hotter than room temperature. Then in the left side, you have kept cold water in the bucket. Okay, let us say if the room temperature is 30, you have kept water of 10 degrees Celsius temperature. Okay. Now, what in the middle? In the middle bucket, you are keeping the room temperature water. Okay, that is the temperature at 30 degrees Celsius. Now, what you have to do? You put or you dip your both hands in one hand in the hot water, another hand in the cold water. The temperature is not such that you will burn your hand or you will get frozen. Okay, it's tolerable. Okay. Now, if you dip your hand and keep it there for some time, okay, then what will happen? You take it out and put it in the normal temperature water. Then what you will feel? The hand which was in the hot water will be feeling cold now, right?
Yeah.
Yes.
And
Right,
the
sir.
hand that was in cold water will be feeling hot now. Correct or no?
No, sir. How it can be?
Huh?
How?
How?
How, sir?
You cannot imagine it. তোমার হাত যদি অনেক গরম পানিতে থাকে, গরম পানি থেকে তোলার পরে তুমি যদি নরমাল টেম্পারেচার ওয়াটারে রাখো, তোমার হাত ঠান্ডা, মানে মনে হবে যে পানিটা অনেক ঠান্ডা। এটা ইমাজিন করতে পারো না? You can do the experiment at your home itself.
Yeah.
Okay. So try to do the experiment at home. I think the others can imagine it, right? And other hand, if you keep it in a very cold water and then take it out and put it in normal temperature water, your this hand will be feeling hot now. So you see, both of the hand are dipped into the same water, but one hand is feeling hot, another hand is feeling cold. So this experiment actually shows by touching, we cannot actually make any assumption about the temperature. Okay, we cannot say the temperature is like this just by touching it. We need to measure it. Okay. Then that brings me to the next topic actually, how we can measure the temperature. To measure the temperature, actually, several devices have been invented. One of them is clinical thermometer, which we use in our daily life. Okay. Nowadays, actually, I don't see it much, but back in my childhood, whenever I used to feel feverish, my mother used to take the temperature of my body by the thermometer. Okay, it shows what is the temperature of your body. that is 100 degree Fahrenheit or 103 degree Fahrenheit. Normal, it is 98.4 degree Fahrenheit. Okay. Acha. Now come to the next page, that is 163. Let us talk about this internal energy now. Are you ready?
Yes.
Yes.
Okay. Today, actually, whatever we are studying, these are all, theoretical things. Okay. We are not actually taking any look into the
Sir,
mathematical
what is the
thing.
normal temperature of body?
98.4 degree Fahrenheit.
4. Okay.
98.4 or 90, around this. Okay. একদম 98.4 না হইলে যে তোমার 94.98.5 হইলে যে তোমার জ্বর হয়ে গেছে, it's not like that. Okay, এটার আশেপাশে থাকবে, and if you are calculating it in degrees Celsius, then it will be 37 degrees Celsius. Okay,
I heard 38.
37.5, sir. 37.5.
something like this. 37.5, 37 একই জায়গায় এক এক রকম করে. I think it actually depends on the weather. Okay, if a person, the people who live in a cold country, I think their normal body temperature will be different from the people who live in the Middle East. Don't you think? This is just one of my assumption. I'm not sure about it. Okay.
Yeah.
It should be. It should be. I don't know whether it is true or not. Okay. So page number 163, internal energy. Let us see what internal energy is. If we accept heat as energy, the next thing we need to know how heat energy is transferred from one place to another. Now we know that heat energy can be transferred from one place to another. Like if we keep two bodies together of different temperature, then the heat will be flowing from the body of higher temperature to the body of lower temperature. Is it correct or not? Did you understand?
Yeah.
Yes.
Yes, yes.
This is true, right? If we keep
Yes.
two bodies of different temperature, if I keep of equal temperature, then it will not be flowing, right? But if we keep two bodies of different temperature, then what will happen? The heat will start flowing from the body of higher temperature to the body of lower temperature. So that is how we can transfer heat from one place to another. Okay. Generally, we think that energy always flows from higher energy to lower energy, right? This is our general thinking. From higher energy to lower energy, the heat will flow. This is actually not true. Okay. Now, why it is not true? A little bit ago, I told you that the heat will flow from higher temperature to lower temperature. I did not say that the heat will flow from the body with higher heat energy to the body of lower heat energy. I did not say that. Okay. So temperature is the deciding factor which will actually tell you that which body will give heat and which body will receive heat. Temperature. Remember, another important MCQ that looking at the temperature, you can see or you can say that which body will be giving it and which body will be receiving it. You cannot decide it by taking a look at the amount of heat energy they have. No. If I give you two bodies and if I tell you the amount of heat energy this body have and the amount of heat energy this body have, so from that you cannot actually say which body will be giving heat and which body will be receiving heat. Or we can say that from where to where the heat energy will flow, we cannot say that. Depending on what we can say that? We can say that depending on the temperature. If I tell you the temperature of these two bodies, then you can say, okay, this body has higher temperature, so this will give heat, and this body has lower temperature, so this body will receive heat. Okay. Now a similar example can be given. That is a figure given in your book 163 page, figure 6.01. You can see, I'm not drawing the figure on the board. Okay, I will just tell you, you just listen to me. Okay, you can see that two pots are there. One pot is very wide and short. Okay, and another pot is thin and long. Now both of them are containing water. If I ask you which one is containing more water,
Ball.
the fat one or the thin and long one?
The fat one, the fat one.
The fat one is containing more water, right? Okay.
This one though.
The fat one is containing more amount of water.
In a long.
But if I ask you
Black
about the
one.
liquid level, which one has higher liquid level?
Thin. thin one.
The thin one has higher liquid level, as you can see in the book, right? So whenever the stop cork is open, you can see that both of the cork is connected through a connecting pipe, and that is controlled by a stop cork. If you open the cork, what will happen? Water will start flowing. Now, from where to where the water will flow? This actually is determined by the water level, not by the amount of water. If we take a look at the amount of water, the fat one has higher amount of water. So one might think, okay, this one has more water, so water must be flowing from here to here. No, the water will flow from the higher level to the lower level. So from the
Like height will be determined.
height, very good. The water level height, this determines actually from where the water will flow to which direction. Just similar thing you have to imagine in case of two bodies. Two pots will be replaced by two bodies, and here in the pot there is water, in the bodies there is heat energy. So looking at the heat energy, which one has higher heat energy, we cannot actually determine the body, the heat will flow from which direction to which direction. We cannot say that. Likewise, in this case, we have to look at the water level, and that will tell you that from where the body, the water will flow to which direction. Likewise, for bodies, the temperature difference, that will tell you that the heat will flow from which body to which body. Understood? Can you relate these two examples? Okay.
Yes.
Okay. So if anybody is, I'm going a little bit fast, I feel. So if anybody did not catch the point, then you may rewatch the video later, and then you may really think about it. And if you still have any doubt, you may let me know in the next class. Inshallah, we can discuss about it. Okay. And I can see that we have almost come to end of our class. So the rest 3 minutes I want to spend actually by asking questions from me. Okay, asking for questions. If you have any question, if you have anything to ask, you may ask, or you may share any experience or unusual experience that you had during this holiday. If you want to share, you can share. I will not force you. It's up to you. Something unusual and something educative that you might think that from this some others might learn. যেমন আমার সাথে একটু আগে যে ঘটনাটা ঘটে গেছে, এটা কিন্তু এডুকেটিভ একটা ঘটনা। গ্লাস যখন ধুতে যাবা, ওকে, ধোয়ার আগে চেক করে নিবে যে গ্লাসের উপরে কোথাও কাটা আছে কিনা। সো যদি কাটা থাকে তাহলে অ্যাভয়েড, ওকে, সাবধানে কাটো, আর বেস্ট হয় গ্লাসটা ফেলে দাও। ওকে, আর যদি কাটা না থাকে তাহলে ইটস ওকে। তো এখান থেকে আমি নিজে একটা জিনিস শিখলাম আর কি। ওকে, তো
আরেকটা জিনিস শিখলেন, হলুদ থেকে লাগালে রক্ত বন্ধ হয়ে যায়। হলুদ লাগালে রক্ত বন্ধ হয়ে যায়।
হ্যাঁ, এটা আসলে আমি একটু মানে জানতে পারলাম আর কি। এটাও একটা শিখার জিনিস যে হলুদ লাগালে রক্ত পড়া বন্ধ হয়ে যায়। এবং হলুদ, আই হার্ড দ্যাট ইট ইজ আ ডিসইনফেক্টেন্ট, মানে যদি ওখানে কোনো ব্যাকটেরিয়া থাকে তাহলে সেটাও নাকি ও কিল করে। আই এম নট শিওর অ্যাবাউট দ্যাট, আই হ্যাভ টু স্টাডি মোর অ্যাবাউট দিস ওয়ান। ওকে, mashallah, I can see only 2 has kept their camera open and the others have closed. I don't know what is the reason for that. From the next
ক্লাস শেষ হয়ে গেছে তাই বন্ধ করে রাখছি আমি। আমি তো চালু ছিল সারা ক্লাস।
ঠিক আছে, no problem. So get ready for the next class. Okay, see you in the next class inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.